Okay, we're going to start with a design that has an axis, and we're going to make the x-axis over here the road surface, and then we're going to have our bridge, and our bridge is going to have some design stuff with it. And as I said before, we'll make sure our bridge is a fairly simple one, but you can be creative and make it look really interesting. Right, so if our bridge is going to be for this, so it's going to be 100 metres wide, and yours is going to be much wider than that, and we say it's going to be quite high. I'm not going to make it too high. Let's say it's going to be 80 metres high. So what's this coordinate point going to be on my bridge? Well, the x coordinate's 100, and the y coordinate, if I'm saying it's going to go to a height of 80, is going to be 80 metres, isn't it? What's this point going to be? 0, and that's going to be 80. And guess where the middle point's going to be? Your vertice point. Let's say it's going to be 20 metres or 10 metres off the thing, or 20 metres. So that point there is going to be 50 and 20. Got the idea? So, what do I need to do to work out the equation of that thing? Well, you need to show off the mathematics. You need to show that you can do it both ways. That's what you need to show. So what two equations do I have? I have y is equal to a x take alpha, x take beta. And what are the x values? The alpha and beta? What are they? They are my x-intercepts, aren't they? Does this curve have any x-intercepts? Not really in that little section we're looking at between 0 and 100. So if this is the case, I can't use that equation, can I? If I've drawn this type of bridge. So therefore, I know, and this is the sort of thing that you need to put in your investigation, is I know I can't use that equation because it doesn't have any x-intercepts. Does that show that you actually understand the mathematics? Hell yeah, it does, doesn't it? It shows that you actually understand what's going on and what you're looking to do. So the one that I have to use is not that one there. I have to use maybe this one here, which is y is equal to a x take h squared plus k, where that point there is in fact my vertice point at hk. Does that make sense? I'm just using my vertice point, I'm going to substitute that in. So what would my h be in this case? What's my h value going to be? 50. What's my k value going to be? 20. So I'm just going to go y is equal to some value a, x take 50 squared plus 20. Right? Why have I got this a value at the front, at the start there? Why do I have this a value? Tell me. What's the purpose of the a value? Are we thinking, or are we just too quiet and don't want to ask? Don't want to put yourself out there to make a mistake? What do you think it does? It does. It multiplies what's inside the brackets. Right? I think we went through this right at the beginning of the topic when we started drawing things. I'll just do this in green. Here's a quadratic that goes through this vertice point. This what you might use this for, making a nice design for a bridge. I might want to actually make a design the bridge where it goes there and has like a fanny type thing. Got the idea? Yeah, well that's it. It changes, what it actually does change, it changes where the curve goes, because even though if you're looking at my poor drawing, right, these are supposed to be all parabolas or quadratic curves, so they all go in that type of shape, don't they? So that's the vertice point, but this curve here also goes through the vertice point, and that will have a different equation, won't it? Yeah? Or that hang on. This curve here can have also a different equation and go through that vertice point as well. That goes a bit strangely different, doesn't it? Does that make sense? So if we're looking at those curves, they all have the same vertice point. So that will be, you know, if we were doing that, we'd go tick, beautiful, no problems over here. You're doing a really good job. The problem is, I could be doing this equation here. It's got that vertice point, but my A value here fixes it to go through the other points on the curve. That is a really crucial thing because it fixes my curve to go through the points that I have on my particular curve, which I've stated. Does that make sense? So I'm going to use those points to help work out what the A equation is. So which points could I use? Well, I've got 2 points I could use. I could use this point up there, or I could use that point up there. Are any of those points better than each other? Not really. They're not any better than each other, those points. Alright? So for this one here, that's what I'm going to do. I'm going to use that point. Alright? So pick a point for me, Craig. 180. So I'm going to use the point 180. So what does that do? 180. Well, what's my y value going to be in this case? 80. When my x value is 100. Take 50 squared plus 20. So straight away, because that's that plus, what are we going to do with that when we bring it across the other side? Make it minus 20. So 80 take 20 is going to be equals A. Now 100 take 50 is what? 50. 50 squared is going to be 2,500. So therefore, in this case here, A is going to be equal to 60 divided by 2,500. Cross the zeros off. Right. And we can say that that's equal to 6 over 250. Happy with that? So then my equation is y is equal to 6 over 250, and then it's bracket x take 50 squared plus 20. Now I'm going to go get the calculators. Here's got a graphics calculator on it. Right, get it out. I'd like you to have a go at graphing that. Right, come and grab one if you don't have one. I'll put a link on the intranet to show you where you can actually get a free version at home, so you can actually put it on your computer. Right. So here, so when I go to my calculator, I'm going to put that into my calculator, and we go y equals, we just clear that. It's going to be 6 divided by 250, and then it's bracket x take away 50 bracket, and we square that, and then we add 20. Alright, and then we graph it. Now you'll have to set your axes right with this, depending on what was the last drawing on here or not. Will give you an idea. So where do you get to set your axes? Obviously your window. Alright, so we can go minus 5. Now x, how wide's the bridge? 100. So maybe we go to 110 so we can see the top points. Alright, and then we're going up in ones, and then we go from minus there, and the top of the bridge is how big? 80, isn't it? So therefore we just go in ones. So if we now graph that, it will give us our curve of our bridge, and it looks pretty cool, doesn't it? Alright, does that make sense? So I've actually modelled that curve shape with my with my modelling here, haven't I? Do you understand why I've done that? I can do multiple curves, so I could also do the ones on the edge as well. So I'm just using my vertice point. So if I trace that, press trace and go across, it's telling you your points there at 52.5, it's 20 something. If I scroll across, it's getting closer to 20. It's pretty well around 20, isn't it? If I scroll across this way, right, you can see the x value and the y value. So if I know the x value, I would know the y value on that curve, wouldn't I? Does that make sense? Alright, so if I knew the x value, I could work out what the y value is, couldn't I? Can you actually do that? There is a way you can do that. On your calculator, if you press the blue button and then the calc button over there, if you press the value number 1 and you say how high is it going to be when x is equal to 10, it'll actually work it out for you. It gives you your answer. So you go blue, the second function calc, number 1, and you go when x is equal to 20. Gives you your value. Right? And if you go second function calc, when x is equal to 30, you get the idea? So it actually tells you how high that is. Now, why would that be useful? Think about it. Why would that be useful? This is a real life scenario. Why would it be useful, knowing that height?
To know the cable length.
Yeah, you're going to probably have to support the road base somehow, aren't you? Okay, that big, the big arch supports the road base. So what you're going to have here, when we come back to our diagram, is I'm going to want to know, let's just get rid of these other horrible curves. What I'm going to want to know is I want to know the length of the cable that goes from there to there, and the length of that cable that goes from there to there, and so on and so on. Alright, so your calculator, your equation works it out. Now, if you did it manually, how would I do it manually? Well, I want to know what the y equation is when x is equal to 10. 250, 10, take 50, squared plus 20. I do that calculation on my calculator, and it gives me a value of 58 point something. Alright? That's what it does. That's what the calculator is doing for you. It's giving you those values, isn't it?
So you put x as to be like whatever you want, and then it'll figure out like what y.
Yeah, it works out the length of that y bit for you. So, because that equation, the x and the y coordinates are in fact everything that's on the blue curve there. They're your x and your y coordinates. Okay, so all a line is made up of is lots of different points. So these are all my x and y coordinates, aren't they? And we're saying that's the shape of my thing. So that allows me to work out the length of my cables, doesn't it? To support that particular thing, which I think is a useful thing. I would also have some cables over here. So by even just doing a simple shape, you've got a little bit of an extension thing to do there. Right? How would I make this a bit more challenging for you? How can I make it more challenging? I could have some other shapes there, couldn't I? Right? So maybe if I was doing this when I'm designing my bridge, and this is what you have to get right, is I might even use an arch bridge. And then on my arch bridge, I might have a section that goes, I might have a couple of little arches in there. And then I might have another little thing there or something like that, I don't know. You can make some different shapes in there. So you can actually show off that you can do the equation of quadratic and you can find the equations. Right? So that's the idea of what we're doing here. Right? once you've pretty well got your equation, it's really a matter of then finding the length of the cables and all that sort of stuff that you need to do, right? So if it's really, really simple and all you're doing is the real routine stuff, you're only going to get a C for this investigation. If you can think of outside the square a bit and extend it, then you've got a chance to get an A or a B, right? So you need to extend it for yourself if you want to get a higher mark than a C. Everybody's capable at least doing the bridge design itself and getting the basic bridge design, right? And getting the length of the cables and so on. Just before I stop talking and let you get into it, I just want to show you how you can do this using Excel. Do you guys use Excel very much? I'll just show you a couple of things with Excel, which is really cool. Jack, can I just get you to flick the light off again, please, mate? Thank you. So with Excel, this is a bit hard to see. I might put grids around these so you can actually see the grids. Format cells, put borders around them, just so you can see the grids. No. Can you see the cells now? I'll just blow it up a little bit for you. Okay, so obviously these things here are really, really useful in terms of you can do lots of calculations, repetitive calculations, where you don't really have to think too much about it. So if I knew, let's say I've got X here and I've got my Y value here, okay, and let's say the equation that we're looking at, let's say we know our X value here is going to be 100 metres, and we're going to go in 10. So we start off at 0, we're going to go 10, we're going to go 20. Now I can keep typing those things in. What I could do is highlight these two cells here. See how I go to the bottom there, it goes to a black cross. I can drag that down and I can then go to 100 and it fills down for me. Got the idea? So now I've got my formula. My formula is equal to, what was it equal to? My formula is equal to 6 divided by 250, and then it was bracket. It was the X value, wasn't it? That cell there, A, is in fact my X value. So I'm going to say it's A3. I click on the cell, and then it's take, was it 50 or 100? Take 50, bracket, then I have to square that. Now the thing it uses on here, it's a bit like your calculator, uses the caps lock. That gives you your power, and I'm squaring that, and then what do I have to add on to that? Plus 20. Oh, you know what I did? I know what I did. I put a space in here. Okay, and I just go into there. Oh, I need to put a times there. A times is the star. Enter. Okay, it works out to be the height of 80. Then if I fill this down, because I've done a formula, it works out all of those things for me really nicely. Okay, so this is another more, it just shows that you can actually use technology, and that's important. Okay, so what it does here, it changes my formula from being A3 to A4. The next one's going to be A5, the next one's going to be A6. So it does that repetitive calculation for me. Now the great thing about this is I can then go to here and I can insert a graph, a scatter graph there, and you can see that I actually have my equation there, can't I? That's my graph there that I've actually got. That matches that. Here, if I click on those dots, and I right click on there, I can add a trend line. My trend line needs to be a polynomial, and I can display the equation, and I can display the r squared value. Enter. And that gives me the equation of my quadratic. One means it's a perfect correlation, which we would be expecting, and that gives it to me in the form of ax squared plus bx plus c. So then I can compare that with what I actually have with all my other stuff that I've got. So I'm comparing things, I'm doing things in a different way to confirm what I've actually got. Got the idea? So that's useful in terms of it's a really nice way of displaying information. Really simple way of doing it. With maths, what we ever want to see is just one calculation. When you're doing lots of repetitive calculations, we don't really care so much about that, but we want to see at least one calculation for that. Okay, and then you can label things into a table, right? Because if you have lots of repetitive calculations, it gets a bit boring for me to mark. I fall asleep. All right, so I don't want that to happen at all. All right, so that is the basics of what you have to do. As I said before, though, to get an A, you have to extend that. So you have to go off on a bit of a tangent, and you need to either make your graph a bit more complex. You certainly have to talk about the limitations, right, about what we're doing there. So you know how we're going to work out the cable lengths? Well, you're going to have to, in reality, allow a little bit longer, aren't you? Because you have to connect them, right? And then things like, you know, if they're made out of metal, we know metal does what? Expands and contracts, doesn't it? So you're going to have to make expansion joints and so on when you're building something like that. So that's in a nutshell what you basically have to do for this particular task.